Explain qualitatively, part B, what would happen to the apparent frequency if the observer moved at constant velocity towards the moving source. So not only do we have this thing moving, we now have our observer moving. So let's draw that again. So here's our observer. Now, we've got, let's say, this is our stationary observer. So he's picking up these wavefronts of lambda. Okay, so we need to draw another line in our picture. So the ambulance is doing the same thing. There's a noise source there, but this time our stationary observer in a time t, or sometime in the future, has moved towards the wavefronts. So let's just think where the wavefronts will go. So again, we're talking, start with this, and we're going to progress it a little bit into the future. So the ambulance will have moved a little bit. Likewise, the wavefronts will have propagated forward. So they're no longer in line with these ones. And the observer will have moved forward as well. So he was there, he is now here. And we can see these are coming towards him like that. He's going that way. He's going to start picking them up more quickly. So observer now meets wavefronts more quickly. So that implies that the period between wavefronts reduces. Frequency here is increases. And in fact, all it is a change of reference, because from the observer's point of view, he could say, well, I'm actually stationary. If I'm moving at speed u this way, I can think of it as me being stationary and the ambulance just having an extra speed u coming towards me. The question says explain qualitatively, means we don't have to do calculations for this. So what we have is that the frequency increases in proportion, because our Doppler formula, that's not quite proportional, because it's V times C over V plus C. So we won't use the word proportional. Frequency increases as the observer, with the observer's velocity towards the ambulance, or towards the source.
The Doppler effect often comes up in these scholarship questions, doesn't it? And that it hangs on that relative velocity between the observer and the source.
So it doesn't matter whether the source is moving towards the observer or the observer moving towards the source. It's the same situation. From the observer's point of view, he can treat himself as stationary and just have the world have that extra velocity towards it.